Before we can answer our final question of whether there is more energy at the top of the ramp or the bottom of the ramp as the vehicle is moving down, we're going to investigate how height actually affects potential energy. So we've got ramp A, ramp B, and ramp C. So we're going to be measuring the potential energy from the top A, the middle B, and the bottom ramp C. So potential energy, as we just mentioned, the equation is mgh. M being mass, g being the acceleration due to gravity, and h being height. So we're actually going to do, I guess you could say, 3 trials. Trial A for the tallest ramp, trial B for the middle ramp, and trial C for the bottom ramp. So if you wanted to make a diagram, you've got 3 ramps here. A, B, and C. And we're calculating the potential energy at the top of those ramps. First, we need to find out what the mass is for each of those trials. Now, since we're using the same car, we only have to find the mass once. Here I've got a digital scale, so I'm going to turn it on. You'll see my units are in G, but if your units were not in G, I would press this unit button. You've got pounds, ounces, milliliters, but we want to measure mass in grams. The 0 is exactly where it needs to be. Sometimes when you turn it on, it has a funny number. You could press this tare button just once and it'll set it back to 0. So I'm going to take my car, put it on top. My car is 37 grams. Since we're using the same car for all 3 trials, so when I come back to my table here, I'm gonna write that down. 37 grams for each one. Then my gravity. So anywhere you are on planet Earth, your gravity, the gravitational pull towards the center of the Earth is going to be the same. So you're looking at 9.8 meters per second squared, all the way across. So what you should have different is your height. So when you're measuring with a meter stick, you need to make sure that you're using a centimeter side. 0 starts at the bottom with a 99 at the top. So if I'm looking straight across, it's kind of hard to see where the 84 centimeters ends. I will just tell you it's at 47.5. As we just said for trial A, our height is 47.5 centimeters. I'm going to go ahead and tell you the height for trial B and trial C just because it's a little difficult to read underneath the track, the ruler underneath the track. So we have 31 centimeters for trial B, and for trial C you have 23.5 centimeters. So please make sure that all of this data is in your notebook. My original equation, potential energy equals mgh. When you have the letters right next to each other, you just multiply all 3 across. So for trial A, 37 times 9.8 times 47.5. Now, some people will see this squared here and think, oh, I need to square 9.8. You do not square it. This is squaring the unit. It is not squaring the number. So again, all you do to find out what potential energy is 37 times 9.8 times 47.5. And your potential energy is, well, I'll let you figure it out, but I will tell you your joules would be your unit, so you'd put a J.